Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Hello, how are you today? Today we will talk about sequence and series. Okay, in the previous video, we already learned about introduction to number sequence. So today we will learn about arithmetic sequence and series. Okay, in arithmetic sequence and series, we will learn about the first arithmetic sequence and then the second about arithmetic series. So now we will continue to arithmetic sequence. Okay, in arithmetic sequence, we learn about the four. The first about definition, the second about general term, the third about advanced general term formula, and then the last middle term formula. So now let's jump to the definition. Definition of an arithmetic sequence is a sequence En has the same different d between its consecutive terms. So if you find the sequence and then you will see the difference from the second term to the three terms and then the fourth term, when you saw them have the same difference, so it called is arithmetic sequence. Okay, remark. In other word, in other word, En is arithmetic if En plus 1 equal En plus D such that N element of natural number and D element of real number. We denote, we already learned in the previous video, En is equal general term of an arithmetic sequence and D is common difference. Okay, in here we have D is divided by 2, arithmetic sequence. Okay, if the common difference plus it's the meaning arithmetic sequence is increasing, it's the common difference minus its meaning arithmetic sequence is decreasing. Okay, example number 1, state whether the following sequence is arithmetic or not. If a sequence is arithmetic, find the common difference. Okay, number 1, 7, 10, 13, 16. We can see from here, the first term is 7, the second term is 10. Because we already know the formula for from the remark, En plus 1 is equal En plus D. So from here, we can see there are half different from the first term to second term. They are different 3, and then second term to the three terms is 3, and then the third terms to the fourth terms different 3. So they have the same difference, and then it's called, yes, correct, arithmetic sequence. And then how about B? We can see B, the first term is 1, the second term is 4, and then the third term is 9, and then the fourth term 16. We can see from the first term to the second term is different 3, but from the second term to the third terms is different 5. Okay, from here we cannot say they have same difference. So this one, it's not arithmetic, everyone, because they have different difference. How about the C? 6, 6, 6, 6. The first term 6, the second 6, the third term 6, and then the fourth term 6. Okay, we know 6 to 6 from the first to the second term, they have different equal 0. And then they continue until the En. So we can say this one is arithmetic with the difference equal 0, everyone. Another example. State whether the sequence with the following general term are arithmetic or not. If a sequence is arithmetic, find the common difference. From here, we have En equal 4n minus 3. So this one is called general term. So we need to find, is it arithmetic? If this one is arithmetic, continue to the common difference. Okay, we already know if the formula from the remarks, En plus 1 is equal En plus D, we just need to follow this one to get the formula for en plus 1, okay? So en is equal for n minus 3, and then we change n to be n plus 1. So we can substitute 4 times n plus 1 minus 3, and then the result is 4n plus 1. So we have en and we have en plus 1. So we need to find d. Okay, this one is from the remark en plus 1 equal en plus d. So we want to find the difference. En plus 1 minus en equal d. So we got en plus 1 is 4n plus 1 minus, open bracket, find 4n minus 3 equal 4. So from here, we get the difference is 4. So this one is called arithmetic sequence. And then the number B, we have en equal n squared plus 5n plus 4 over n plus 4. From here, you can see from the numerator, if they can factorize, you can factorize first. Because from here we can do factorize, you can cancel between numerator and denominator. So en is equal n plus 1. Because after we cancel everyone. So we need to change n to be n plus 1. And then you need to change from here and then here too. So you will get the general term for n plus 1 is n plus 2. And then you need to find the difference again. You just need to simplify this one, and then you will get the common difference is 1. So this one is called sequence arithmetic. I hope you understand what I'm explaining. Okay, now we will talk about the general term. What is general term of the arithmetic sequence? If en is arithmetic, then we know that en plus 1 is equal en plus d, such that n element of natural number and d element of real number. Let us write a few terms. Okay, we already know if the first term is equal first term. Okay, and then if we want to find the second term, we can substitute n in here 1. So this one, the second term equal, because we are using n in here 1. So in here is a1, the first term, plus d. And then how about the third term? So the third term is that the meaning they put the n equal to, right? So n is 2, 2 plus 1 is 3. And then in here, a2 plus d, because we got the a2, the second term is a1 plus d, so you need to substitute from a2 to b a1 plus d plus d. So from here we get a1 plus 2d, and then you continue until you get a5 equal a1 plus 4d. So you get this formula en equal the first term plus n minus 1 times d. So this one is general term formula of an arithmetic sequence with the common difference d. Okay. Okay, example number 3. Minus 3 to 7 are the first three terms of an arithmetic sequence. Find the 20th term. Okay, so you can write the first term is minus 3, the second term is 2, and then the third term is 7. So we already know to find the difference. Difference is the third term minus the second term, or the second term minus the first term. So when you can using the both of them to try to showing that the difference is correct. So you will get the difference is 5. And then because they're talking about the find the 20th term, because we already know about the general term is the first term plus n minus 1 times d. So because we want to find the 20th term, so you need to change n to be 20. The 20 term equal minus 3 plus 20 minus 1 times 5. The result will be 92. Okay, the fourth example. En is arithmetic sequence with the first term is 3 and then the common difference is 4. They want to ask is 59 a term of the sequence? Okay, they want to ask to answer 59 is it term of the sequence or not? Okay, so we want to continue this one. For 59 to be a term of the arithmetic sequence, it must be satisfy the general term formula such that. Okay, we in this question we get the first term is 3 and then the difference is 4. So we have En equal the first term plus n minus 1 times d. Okay, they're talking about the 59. So you change the n term or in general term to be 59 and then you need to substitute a1 to be 3 and then n minus 1 times 4. You need to simplify this one. You get 59 equal 4n minus 1 and then you get 60 equal 4n. So n equal 15. So the answer is 59 is term. Yes, but in the 15 terms. So that's the answer. Okay, now we have number of the terms of a finite arithmetic sequence. Okay, in here we have general terms. En equal the first term plus n minus 1 times d, right? So from here, we simplify this one to be En minus the first term equal dn minus d because they're talking about number of the terms because we want to curious about the number of the term. So you can get the formula to be n equal the n term minus the first term over d plus 1. So this one is called the n of the number terms if they have the n term and then the first term and the common difference. So you can using this formula. Okay, example number 5. How many two-digit number are visible by 5? Okay, you can think what's the two-digit number, right? So you can solve this one because they are asking about two-digit number. Two-digit number divisible by 5 is the first term is 10. And then the greatest two-digit number divisible by 5 is 95. So we don't know how many n of this one until 10, 15, 20, and then etc. until 95. So we have difference in the 5, and then we have the first term 10, and then we have the n term is 95. So you need to find the n. You can using this formula. So n equal the n term minus the first term over d plus 1. N equal 95 minus 10 over 5 plus 1. So n equals 17, everyone. So from here, we already learned about definition and the general term. So the number 3 is advanced general term formula. Okay, in advanced general term formula, okay, in here is En is arithmetic sequence with the 11th term is 34 and then the common difference 3. You need to find the third terms. You can using the previous general term, but you can using the advanced general term. But now we will try to answer using the general term. So general term is the n term equal the first term plus n minus 1 times d, right? Because we have the 11th term is 34, so you can change the n to be 11. The 11th term equal the first term plus 11 minus 1 times d. 11th term is 34 equal, because we don't know the first term, you need to find the first term. And then you get the first term is 4. And then you can continue to find the third term using the general term. General term is en equal the first term plus n minus 1 times d. So you need to change n to be 3. So the third terms equal the first term plus 2d equal, because the first term is 4, plus 2 times because the d is 3. So plus 6 equal 10. So the third term is equal 10. But from here, we can using the advanced general term without finding the first term, everyone. So let's say if we know the p term and d, and then to find the n term, okay, we can using the general term to get the formula. The general term is just from the 1 and then from the 2 you can subtracting each other. Maybe you're curious why I'm using n, why I'm using p, why I'm using n. It's just variable, everyone. It's okay, it doesn't matter. So from here, when we subtracting 2 from 1, we get en minus the p term equal n minus p times d. Because we have the purpose to get the n term, so the n term is equal the p term plus n minus p times d. So from this question again, you can using this advanced general term if there's no the first term, and then if the p is less than n. Okay. So example, En is an arithmetic sequence with the 5 term is equal 14. You need to find the 10 term equal 34. Find the common difference. So we know we have the two terms, 5 and then the 10, and then we can see the p is less than n, which is p is 5, n is 10, and then you just need to simplify this one to get the difference, because we don't need to find the first term, and then there in the equation there's no the first term too, so you can using the advanced general term if they have the two of the terms. So when we simplify this, we get the difference is 4. How about another example? Okay, in another example, they have sequence with the 9 terms minus the second term is equal 42. Find the 10 terms minus the 7th term. So from here, we can fix the first. Fix the first of what? We need to find this the 9th term minus the second term is equal 42. Okay, we're looking if the n is 9, if a pair is 2. Okay, and then when we substitute n and p, so we get the 9 terms equal the second terms plus 9 minus 2d, and then the 9 terms minus second term is equal 7d. We have the 9 terms minus second term is 42. So 42 equals 7d. And then we simplify, d gets 6. Okay. And then from here, you need to find the 10 terms minus the 7 terms. The 10 terms is the 10 is bigger than 7. So we can using this formula again. And then because we have d, you need to substitute d. And then you get the 10 terms minus 7 terms is 18, everyone. I hope you understand about this one. How about another example? 4x, y, z, and 25 are 5 consecutive terms of an arithmetic sequence. Find x, y, and z. In this question, we are looking for what? For the first term are 4, and then the 5th term is 24. So in here, we have the first term. So you can using the general term or you can using the advanced term. It's depend on you. So from here, we know the first term is 4. So because we want to, the purpose to using the advanced advanced general term, we can symbol the first term is 4, we can symbol P. Okay, and then 4 to 24, 4 to 24 is P plus 4. Is that the meaning? P is 1 and then P plus 4 is 5. So we can using this formula to find X, Y, and Z. Or if you want to use general term, it doesn't matter. So you will find that D equal 5. And then you will get X and Y and Z. Okay, everyone? And then for the number 10, given an arithmetic sequence with the nth terms with the eighth term is 10, and then find the second term plus the 14th term. So from here, we just have 8 terms and then 2 and then 14. So you need to connect the second term with the eighth term and then the 14 terms with the 8 terms. Okay, looking again for the advanced general term formula, they told us if n is more than equal than p, right? But in here is the exceptional because for the number 1, we have the smaller value than the p, but the purpose we want to continue to get the second term and then the 14 terms. From here, you just need to substitute A2. The second term is the equal x term. So, because in the 2 is n, so 2 minus x times d. And then for the 14th term, x terms plus 14 minus x d. You need to adding equation the both of them. And then you will get the second term plus the 14 terms is equal the x terms minus 6d plus the x term plus 6d. So you can cancel 6d and then you will get 2 x terms. You can substitute the x terms 10. So 2 times 10 is equal 20. So this one is exceptional, but this one, the purpose, you just can using the x term. Is okay, everyone. I hope you understand. Now we will talking about the middle terms formula. In middle terms formula is the famous name with the arithmetic mean. Okay, in arithmetic sequence you can using the p terms is equal the p minus k terms plus p plus k terms over 2 where k is less than p. So that's the rule. Where k less than p. So, okay, example. 11, 5x, 19 are 3 consecutive terms of an arithmetic sequence. Find x. We know 5 is the first term, x is the second term, 19 is the third term. We want to find the second term, so we can using the second terms is equal the 2 minus 1 terms plus 2 plus 1 terms over 2. Okay, because the second term in here, they are in the middle of between the first and then the third. So when we substitute, 5 plus 19 over 2 is 12. Okay, number 12. Find the general term En for the arithmetic sequence with fifth term and then plus 21 terms is equal 106 and the ninth term is equals 37. So from here, you need to find what's the middle of the 5 terms plus A21. Okay, so in here, the 5 terms plus 21 terms over 2 equal 13 terms is equal. Okay, because we have this one value, so we can substitute 106 divided by 2 equal 53. The third terms equal 53. Okay, because we are looking for the ninth, the general term, we have the third term and then we have the ninth terms. You can substitute to get the D. Y is 4 means this one is coming from 13 minus 9. So you get the D difference is 4. So we know the general terms is the 9 terms plus n minus 1 times D. Why are you using this one? Because we don't have the first term, so we can using the advanced general terms. So the advanced general term, we substitute the 9 terms because we have they give us the 9 terms is 37. You just need to simplify and then you get the general term is 4n plus 1, everyone. Okay, I hope you understand about middle terms formula. We are done for arithmetic sequence. So for the now we have exercise. You can open your Jambox book and check yourself 5 and 6. Please do it in your homework, and then you need to try to answer. And then for this next meeting, we will talking about the arithmetic series. Okay. So everyone, I hope you understand what I'm explaining today. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.